we want to examine the gradient of the curve, all right, of a function. In other words, the gradient of a function. Now, here we have this function, which is x squared minus 3x minus 1. Now, let me put down my blue line down here. I'm going to be using it. Let me make it a bit more straight. All right, good. Let me zoom in to this part of this graph. Question. You might ask, what is the gradient of this graph when x is equal to 0.6? This is 0.6. I'm going down here. Right? What is the gradient of the graph at x equals 0.6? Let's see. I'd have to lean my line here and imagine that I allow this line to just touch that point. You can find, well, let me say this is a tangent because it doesn't cut across the curve, right? Now you can find the gradient here by forming a right angle triangle. If you're doing it by drawing, forming a right angle triangle, these lines are supposed to be straight, and then you use the rise over run formula, but that would be an estimate of the gradient. So remember now, we can use differentiation, and I might ask you, what is the gradient of this function when x is equal to 0.6? Let's see. X squared minus 3x minus 1. So you can say this is y equal x squared minus 3x minus 1. What you do is differentiate to find the gradient function, which is the derivative. dy by dx is equal to 2x minus 3. And when x is equal to 0.6, then dy by dx is equal to 2 times 0.6 minus 3, which is 1.2 minus 3, right? So we have 1.2 minus 3 in this case. 1.2 minus 3.0. We're going to have 3 minus 1.2, and then we'll have a negative value for it, because 1.2 minus 3 is a negative number. But let's say 3 minus 1.2. So you work this out, and you get 1.8 is the gradient of this curve at this point, 0.6, right? Now, I could also ask, what is the gradient when x is equal to 2? Yeah, this looks like 2. What's the gradient of the curve at that point? Right? It looks like about that point. You can do it by drawing. Let me do it by drawing here, although doing it by drawing will give you only an estimate of what the gradient is. So when I put it against the curve, so that it becomes a tangent to the curve, all I need to do now is make my right angle triangle, right? Trying to draw a straight line here. So as usual, rise over run is the formula to use to find this gradient. However, you can use differentiation to get the exact value of the gradient. So let's erase these. We want the gradient of this curve when x is equal to 2. What you have is y equal x squared minus 3x minus 1. Then you differentiate dy by dx. No, you did it before, but just do it again. Is equal to 2x minus 3. And at x equal to dy by dx is equal to 2 by 2 minus 3, which is 4 minus 3, which is what? 2 2 is 4 minus 3, 1. So the gradient would be 1. Alright? That's the accurate value of the gradient. Probably if you use measurement and estimation, you get close to 1. It could be 0.95 or something like that. It could even be 1.05, 1.1 or whatever it is. What you really want is the gradient, an estimate of the gradient when x is equal to 2. Now, let's look at one more thing. A question might ask you, what is the gradient of the function, or at what value of x is the gradient of the function 0? Alright, so x, let me write here, x for gradient equals 0. Now, at what point does that occur? Let's see. If we consider this as a minimum point on the curve, right? And we try to measure or estimate the gradient of the curve at that point, this is what we'd have to do. Something like this. And you go up to just touch the curve, not to cut across it, just touch the curve. The gradient of this line is 0. Right? If you draw this line and it touches the curve there, and it's a horizontal line, it means the gradient of that line is 0, because the gradient of a horizontal line is 0. But let me suppose that you are given this function. Let me be reminded of it. X squared minus 3x minus 1. So the function is, say, y equal x squared minus 3x minus 1. How do you get an accurate value of x when f of x, or when the gradient is equal to 0? Now, y equal x squared minus 3x minus 1. Remember the power rule? We say dy by dx is equal to 2x. No, it's just 2x to the 1, to the power of 1. So what we have is 2x minus 3. That's the derivative. All you need to do now is put 2 into this equation. If you say 2 by 2 minus 3, it will give you 4 minus 3. Right? Oh, not 2. My mistake. It's not that you would do. We have the gradient function here. 2x minus 3. Good. we don't know where the gradient of the graph is 0. But if this gives the gradient of the graph, and we want to find out where the gradient of the graph is 0, we just equate this to 0, so that we have 2x minus 3 equals 0. Right? Now, when we transpose here, we're going to get x is equal to 3 over 2, which is 1.5. Let's see if we could be right. Now remember, what we're looking at is right here. It's supposed to be a straight line. Let me see if I can draw it again. Draw it more slowly. Alright, so here the value of x, where the minimum value occurs, would be 1.5, and I got 1.5 here. Right? It's halfway between, it's halfway between 1.4 and 1.6, which is 1.5. So that's where the minimum value occurs here. Right? And at that point, the gradient of the curve is equal to 0. Now, let's do one more thing. One more. The general form of a quadratic function, oh no, I got this line through here by accident. Okay, the general form of a quadratic function, y equal, or you could put f of x equal ax squared plus bx plus c. Now, at the minimum value, or it could be the maximum value, the gradient is 0. So how do we get that formula, that equation that gives us the gradient, or that gives us the minimum or maximum, that is when the gradient is 0? What we do, we differentiate this and say dy by dx is equal to 2ax plus b, and then at the minimum or maximum value, this is equal to 0. So when you transpose, we get 2ax is equal to negative b, and we divide both sides by 2a, so we get x is equal to negative b over 2a, and that is the equation of a line that would pass through the minimum or maximum point. That is, when x is somewhere here from the minimum point, you project upwards to the x-axis until you and then you identify which particular value it would take. So you would draw this straight line up to the x-axis, and you see where the value is on the x-axis, that this line that I just drew touch the x-axis. All right, so remember, at the minimum point, the gradient of the curve is 0. Right? The gradient of the curve is 0. If you draw the tangent to that curve, you're going to get a horizontal line. Alright? Let us continue this in a different video. So I will see you then.